Finally, the thymus. The thymus, like a lymph node, has a very distinct cortical region that is easily distinguishable from the interior medulla. But unlike a lymph node, certainly there are no germinal centers because there are no B cells present in the thymus. We know that the thymus, as we said earlier, is a primary immune organ because, like the bone marrow, it is a maturation site. In this case, certainly the thymus serves as a maturation site for precursors of T cells. T cell precursors must exit from the bone marrow, arrive at the thymus via the vascular circulation, and as these T cells develop, they are developing an intimate contact with the epithelial cells, mainly in the cortical region of the thymus. And because of the extensive branching of the epithelial cytoplasm, there is extensive interaction that's possible between the thymic epithelial cells and the developing T cells in the area of the thymic cortex. Note that almost 95% of the T cells die in the thymic cortex because of improper selection. Here is a histologic view of the thymus of a child, if only because it has a well-developed areas of thymic cortex and medulla and lacks the adjacent adipocytes that are characteristic of a thymus of an adult. Note that the thymus is organized prominently into lobes or lobules separated by connective tissue, but and in addition to that lobular configuration, we can see that the cortex is darkly staining, mainly, and that's the area where we find the blood-thymus barrier, and you can see that's easily distinguishable from the lighter staining medulla. Again, here is a higher magnification view of the darker staining cortex and the lighter staining medulla, and points out the location of one of the distinct histologic features of the thymic medulla, and that's the presence of the Hassall's corpuscle. Hassall's corpuscle has been long known or thought to be remnants of degenerated thymic epithelial cells, but now we know that those epithelial cells that are in a Hassall's corpuscle secrete lymphopoietin that stimulates T cell maturation in the medulla.